Hello, today we also want to talk about quadratic equations, and we are going to solve quadratic equations using differentiation, using calculus. Those who have done calculus, you are aware of the concept of differentiation. Now, quadratic equations can also be solved using differentiation. Then let us see, how do we do this? How do we use differentiation to solve a quadratic equation? Now, in differentiation, we know that if you are given any equation y equals to ax to the power of n, if you differentiate this, that means you find the derivative of y, then it means dy dx equals to n, you multiply by a, then you multiply by x raised to the power of n minus 1. We bring the power before the number, pre-multiply before x, then the power you subtract 1. That's how you carry out differentiation to find the derivative of a function. Therefore, given any quadratic equation ax squared plus bx plus c equals to 0, then it means that the derivative of ax squared plus bx plus c should give us or is equal to the root of the discriminant. The derivative of x squared plus bx plus c equals to the square root of the discriminant, which is b squared minus 4ac. So this is the formula that we are going to use, the formula of differentiation that is going to help us to solve quadratic equations. So we can use differentiation to solve for x in the equation x squared plus 4x minus 12 equals to 0. Now from this equation we can establish that the value of a is 1, the value of b is 4, and the value of c is negative 12. So putting it in our equation says that the derivative of ax squared plus bx plus c equals to the root of the discriminant, which is b squared minus 4ac. So it means, equating the equation here, it means that the derivative of x squared plus 4x minus 12 should equal to the discriminant, which is b squared, that is 4 squared, minus the product of 4ac, that is 4 times 1 times negative 12. So this one translates to the derivative of x squared plus 4x minus 12 is 2x plus 4. And on the right hand side, you have the square root of 64. So 2x plus 4 equals to the square root of 64, which is plus or minus 8. Now we are going to find the value of x when the square root is positive, also when the square root is negative. So we'll start with when the square root is positive. Now 2x will be equal to 8 minus 4. That is when the square root is positive 8. 2x equals to 8 minus 4. Therefore, 2x equals to 4. Therefore, it means that dividing by 2 both sides, then x equals to 2. Or we're going to find the value of x when the square root is negative 8. So it means that 2x plus 4 equals negative 8. So that means 2x equals negative 8 minus 4. And this one translates to 2x equals negative 12. Divide 2 both sides, and you end up with x equals to negative 6. So you can see we have used differentiation and the discriminant part of the quadratic formula to find for the value of x in the above quadratic equation. We can look at another example. 4x squared plus 4x minus 3 equals to 0. So we need to establish that the value of a is 4, the value of b is also 4, and the value of c is negative 3. So from here, we can recall the formula that the derivative of ax squared plus bx plus c is equal to the root of the discriminant. So it means that the derivative of that equation should give us the root of the discriminant, which goes down to 8x plus 4 equals to square root of 64. So it means 8x plus 4 equals to the plus or minus square root of 64, and that is 8. So 8x plus 4 equals to plus or minus 8. So we are going to find the value of x first of all using positive 8, and second using negative 8. So when the square root of 64 is positive 8, it means that 8x equals to 8 minus 4. So it means that 8x equals to 4. Therefore, it means that the value of x equals to 4 over 8, which simplifies down to a half. Or when the square root of 64 is negative 8. So it means that 8x equals negative 8 minus 4, which simplifies down to 8x equals negative 12. Divide both sides by 8, then simplify, and you find that 8 equals to negative 3 over 2. So you can see that differentiation has helped us to find the values of x in this quadratic equation. We can look at another example also. 4x squared plus 12x minus 9 equals to 0. So going ahead, you extract the variables a, b, c. So a is 4, b is 12, and c is negative 9. Recall the formula that the derivative of ax squared plus bx plus c should give us the root of the discriminant. So it means that if you equate the equation inside equals to the root of the discriminant, it simplifies down to 8x plus 12 equals to the square root of 288. Now, 8x plus 12 equals to the square root of 288, which is plus or minus 16.971 to 3 decimal places. So it means that 8x equals to 16.971 minus 12. So that is when the square root is positive, and it simplifies down that 8x equals to 4.971. Therefore, it means that the value of x is 4.971 divided by 8. So you divide 8 both sides, and x gives us 0.6213. That is to 4 decimal places. Or find the value of x when the square root of the discriminant is negative. And you find that 8x equals negative 16.971. From it you subtract 12. So this one translates to 8x equals negative 28.971. Divide both sides by 8, and you get that x equals to negative 3.6213. So you can see that differentiation can also help us to solve for the value of x in a quadratic equation, or finding the unknown in any quadratic equation. All you need to know that the derivative of the equation should give us the root of the discriminant. Thank you for watching and learning. You can like and subscribe to my Facebook and YouTube channel. YouTube Ombisi Online Math, Facebook Ombisi Online Mathematics. Thank you.